Welcome everybody after a short break. Now this is the time for the last, but not least, of course, presentation. Together with me is Summer Akkoub, and Summer will tell us something about running CI/CD in a multi-cloud platform with GitLab pipeline. So hello, Summer. Nice to meet you.
Okay. Nice to meet you. Thank you. Thank you.
Yeah, so again, I really like to see some kind of practical examples because always we can talk about theory of doing something, but it's always good to do something working. So
Absolutely.
my question at the beginning is why to use one single tool for different clouds? It's kind of controversial question, but I would like to
Yeah,
start.
yeah, yeah. Yeah. No, thank you. Thank you. That's actually a great question to start with. And maybe I will cover more details in the session, but the short answer is uh, developers and as customers, it's not really our job to glue tools together and keep jumping between different siloed tools, right? And I think you agree with me. You are coming from architecture point of view. Our job is really to produce something useful for our end users, right?
Yeah,
So
exactly.
having one consolidated tool means streamlined experience for the developers, for the users, less risky and more efficient delivery cycle for our applications. But as we will see today, that does not mean that I have to use one cloud vendor per se. It's the flexibility of choosing the best platform, but at the same time having less overhead on my developers to choose between different tools.
Yeah, exactly. I totally agree with you. And at
Thank
the end
you.
of the day, we have to just deliver the aim, deliver what users needs. It doesn't matter
Exactly.
tools which will we use. Yeah, so it's that is the
Exactly.
most important thing. So okay, the floor is yours, and keeping fingers crossed for you and for your presentation.
Thank you very much. And I'll start by sharing my screen here. And yep. And here we go. Excellent. I hope you can see use my screen well.
Yeah, we can.
Yep. Thank you very much. Awesome. Thank you very much for this excellent chance to speak at this conference. So let me start by introducing myself. My name is Sam Akkoub. I'm a senior alliances and channel solutions architect with GitLab. I'm based in Melbourne, Australia, so it's almost midnight here. But I'm still so excited to be talking about how we can run really a CI/CD pipeline in a multi-cloud platform with GitLab pipelines. Right. So before jumping into the technical details or aspects of this, cover quickly together what are the really the benefits of having multi-cloud. Why are we even having this talk today? So I think you would agree with me that a greater flexibility is a mandatory thing, right? Nobody wants in the business, nobody wants to hear that we have to use cloud X or Y because simply we are unable to run or migrate our workload, right? The decision, the driver to choose the cloud should really comes from the business, not be imposed or forced by the IT. Workflow portability today, with the different offerings from the clouds and different cloud providers, we all are very keen to have the best services within the locality of the where the actual business and applications are running, right? So it does not mean that if I have my applications themselves running across different cloud providers for their own reasons, that means that my automation pipeline should also follow the same model and should be able to support this deployment with the minimum risk and minimum exposure of my data. Better acquisitions, I think most of the companies today, or let's say many of the companies today in the market, or many of the business today in the market have experienced that, like, we are acquiring a new business, we are adding new technologies and applications to our footprint, and we want to be able to run our automation pipelines across the environments where these applications are running. Increased resiliency is a very, very important point. I've heard it so many times that I want to avoid vendor lock-in, and I want, as a business owner, to have the flexibility to migrate my workload from one cloud vendor to the other. Now, that migration means that I'm not only moving the workload execution, but also I'm moving the execution of my automation pipeline or my automation jobs, which means that pipeline should be able to run across multiple cloud. Improved cloud negotiations. Cloud vendors don't like that. This we as owner, as customers, as consumers of cloud, we love this. It is when you have the flexibility to migrate and to run and to choose the best cloud offering in the market, you have the power to better negotiate the terms and conditions of your cloud consumption. So these are just some of the benefits of why we should run or why we should really care and plan and take into consideration the execution of multiple cloud or the ability to run in a multi-cloud environment when we choose our automation pipelines. Now, nothing for free. There is no free lunch or free dinner, if you like, depends on your time zone, right? So there are always challenges when you choose multi-cloud strategy. It doesn't come really for free. On top of the list is the security challenge, are the security concerns. So basically, when we talk about security, there are many aspects to this. But the most common one when I run in multi-cloud is that most of the time I have my automation pipeline hosted somewhere within one cloud vendor or even within my data center. But my actual workload is distributed across multiple cloud, which means that I am traversing the internet every time I need to execute my workload, right? That's a big concern and a big risk, especially for security and networking team. And handling that is a crucial thing to get their approval to run in a multi-cloud environment, right? Difficult to achieve in terms of workload portability. And I'll show you, hopefully, in the demo how we can even standardize the operation of my workload or my automation pipeline, because simply we are talking about different technologies, right? And we are talking about different hosting platforms. And when you talk about moving between one cloud from one cloud vendor to the other, so how can we even standardize this operation, right? How can we streamline that operation? Data governance, right? So again, you are distributing your workload. You are distributing your execution of the automation pipelines across multiple clouds. So it becomes crucial to have a full visibility on what is running what, where, right? And it's crucial to have proper compliance controls on your coding, because now I'm not only, if I have a vulnerability in my code, I'm not only vulnerable in one point, I will be literally vulnerable across a huge platform that is already being executed across multiple cloud vendors. So these are challenges that exist with a normal consumption of the cloud, but they get magnified when you move into multiple cloud environment. Cool. So how can we, or what are really the types of multi-cloud? And that may sound weird when I say types of multi-cloud, but from having discussions with so many customers on while they are preparing and they are planning for their multi-cloud strategy, I feel that there are different views on or different angles when they refer to the multi-cloud idea. So I thought just to summarize a couple of them, right? So on the left, this is how things are organized in GitLab platform. And for those who don't know GitLab is an end-to-end DevSecOps platform that covers the whole life cycle for having an automation or a DevSecOps life cycle all the way from source code management, from security scanning, from continuous integration, auditing and compliance, continuous deployment and continuous delivery, uh, 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 along or as well as integration with Kubernetes or services, cloud services similar to the Kubernetes cluster. So on the left, this is how things are organized in GitLab. It's like you have the overall organization structure, and then you have groups, and under them you can have subgroups and then projects. And the project is the building entity in GitLab where you have your source management and CI/CD capabilities running. So when we talk with customers and when they describe their requirements for multi-cloud, some of them are referring to multi-cloud as simple as I have 3 different teams, or more, can be more. I'm just taking 3 as an example. I have multiple teams, I should say, and each of these teams, they have their own dedicated, their own preferred cloud provider. So just to make things, take things to the extreme, imagine that you have 3 teams or groups inside the organization. One is preferring for their own application, is preferring AWS, the other is working on an Azure, and the third one is working on Google environment. That's totally fine, right? And this is one view when we say I am, as an organization, I am running against multiple cloud environments. And in that case, things are pretty simple in GitLab, because simply in GitLab, the automation jobs are executed on what we call runners. These are the engines that are responsible to pull the automation jobs from the automation or the end-to-end pipeline and execute them locally within that runner, right? So in this case, we can have runners literally deployed across multiple cloud providers. And by deployed, I mean they can be, as you can see, they can be hosted anywhere from Kubernetes pods or pods on running on Kubernetes clusters, or even as containers, or even directly as on the shell of VMs in the cloud providers. And it is not it's not an or. It does not need to be an or, right? It can be an and. Multiple cloud, multiple runners deployed. Each runner can be assigned to a job, not even to the whole pipeline, and the pair job will be pulled to be executed in the runner and be executed within that cloud vendor. Now, nice thing here is that for each of these tenants or groups, they feel that they are working in complete isolation from the other tenants, regardless of how you consume GitLab, whether you are consuming GitLab through the SaaS offering, GitLab.com, or a self-managed GitLab instance. It doesn't make any difference. I have runners, the execution engines. These runners will be hosted or deployed by the tenants. Each tenant can deploy their own runner within their environment. The relationship between the runner and the actual GitLab server is a pull, right? Which means the runner will reach out to the server and say, Mr. Server, where is the pipeline assigned to me? Where is the job assigned to me? If you have any need for that job to execute, I am here to pull and execute that job locally. Now, nice thing here I have to highlight is that because the runner is running inside the tenant environment in the cloud provider, and let's take here just an example. Let's take AWS. It's running within the VPC, within the subnet. It's running literally next to where the actual automation job will be executed. Customers love that, because that means the runner will reach out to the GitLab server. The GitLab server will know exactly what is the IP range the runners are registered against, and that's exactly what will be whitelisted on the GitLab load balancer. It would reach out there, pull the job, and that's it. It is executing within the VPC, within the network of the tenant, and that applies to each and every cloud provider. Tenants, that's alone. does enough for many tenants to move their workload into GitLab, because from security point of view, I can put my own security rules on the runners, because these are my components running within my area of execution. Same applies for the Azure, and same applies for the Google Cloud. Runners deployed and within their environment, they are registered or assigned to GitLab groups or projects. And as you can see here, I'm connecting them to a group, but they can be registered against projects. And even within the project, as I said before, they can be assigned or mapped to a specific jobs inside that project, and that job can be pulled and executed inside that run. So again, this is one view of when we say multi-cloud architecture. The second view I want to show you, and this is more like maybe you feel it is a little bit busy slide, but what the story I'm trying to tell here is uh, I not necessarily that I have multi-tenants, and maybe within the tenant itself, within one project, I have the need to run test, staging, and production environments, each on a different cloud provider. I can give you an example. I have worked with customers where they are like, it's okay if we do the testing and staging in the cloud, but the production should be deployed on-prem within my data center. You see what I mean? It's not that I have different pipelines. It's not that I have different projects here. It's just the same project. It's one unified pipeline, but within that pipeline, okay, itself, just one pipeline, right? I want to run that pipeline against multiple environments, right? And this is what you see here is the end-to-end, a simplified view maybe, of an end-to-end GitLab pipeline. It starts, GitLab, by the way, it covers the agile project management, or agile portfolio and project management capabilities. I can have tickets or issues, what we call them. I can have group these issues in epics. I can literally plan for my work, assign milestones to my issues, and then link the issue or the ticket, if you like to name it, along with a merge request, which is similar to pull request in other tools, which is basically I'm creating a branch to start working on my change that is assigned to an issue. So basically, I am picking a work item in simple words, right? And this is where, as you can see here, the create merge request will create for me that branch, and I'll start doing the development there as a developer, because GitLab comes with a complete security and vulnerabilities management, including the SAST, static application security testing, dynamic application security testing, container scanning, license scanning, dependency scanning, and fast testing. I can, as a developer, run the security capabilities on my branch, on my changes, right? And deploy a preview of my code against one of the cloud providers. And mainly if you are using, especially if you are using Kubernetes cluster. So and I will show that to you in the demo, right? And from there, once I'm done, I'm happy with my changes, I will submit that for approval, and then the code will be deployed against different environments. So this is, I tried to simplify things here a little bit. And here I'm using what we call GitLab agents for Kubernetes. So let me move to the next slide, and I'll come back to that one. So what do we mean by GitLab agents? Let me start with that one. Think of it this way. Today, I can deploy, as I said before, I can have my runners, okay, deployed or hosted within even Kubernetes clusters, and then from there I can pass the workload or the item or the job, the script to that execution runner, and let it run the deployment job from my Kubernetes cluster, and push the code to be deployed to the different environments. How can we simplify things? We can use what we call GitLab agents for Kubernetes, which are basically agents that can be deployed or hosted within. Actually, they have two main parts, right? One part. Let me switch here. One part is what we call the agent or the client side, which will be hosted within the Kubernetes cluster. Think of it as it's a pod will be deployed in the Kubernetes cluster, but that pod will be communicating with the server side of that agent, which has the configuration for that Kubernetes agent. The main thing what we're trying to do here is once I have a Kubernetes agent deployed in one cluster, then I can generate a kube context for that cluster, right? And I can even pass it to the projects. And then these projects can simply use that kube context, as you can see here, to deploy and communicate with that backend Kubernetes cluster. Again, let me simplify things. In normal life, in order to deploy into a Kubernetes cluster or to have a direct deployment into the Kubernetes cluster, you need to have a runner, an execution runner running within the Kubernetes cluster, right? This is like the normal thing. Or at least you need to have the credentials, right, to connect to the Kubernetes cluster. I'm talking here about multi-cloud environment for cloud native applications, and we are deploying Kubernetes cloud native containers to these Kubernetes clusters. Now, to avoid that manageability and security concerns of having direct connection to the Kubernetes cluster, what you can do is simply you can host a pod inside, excuse me, inside that Kubernetes cluster. What that pod can and should be or can do, it's your control, because you are controlling it simply as any normal object within the Kubernetes cluster. So you can set the RBAC rule, the RBAC policies for that Kubernetes cluster. Now, the thing is, once I have it, I can have a project inside GitLab. As you can see here, I will have 3 projects. Each of the project job is basically to be the server side. It's just a normal GitLab project, lives within GitLab. But basically what it's doing is it is like the command and control of that agent. So it is basically I am controlling from that project the generated Kubernetes cluster context where it should be passed to which projects. The value here is that, as you see in the diagram, I can have agents literally sitting in each of these different clusters across multiple environments, right? Or multiple, even multi-cloud environment, right? And then I can pass this context and actually the ingress-based domain. I'm using Nginx ingress here to my simple Node.js project, the project at the top, and then it becomes my choice which context I want to use for which environment, right? I will show you how that is a very simple deployment. So this is like a summary of what we can do with these agents. Like there are 2 sides for that one: the CI/CD workflow and even the GitOps of the side. The CI/CD workflow, as I described before, the agent will enable me to create a kube context for my Kubernetes cluster, and then pass it to the target projects or even group of projects, and then ask them or let them communicate with the Kubernetes cluster through the GitLab agents for Kubernetes. Also, what you see on the right, the pull-based, I can automate the deployment or the GitOps deployment. Basically, because control of that agent lives in the server, I can ask that project to monitor certain projects or folders in certain folders in that project, so that whenever any changes happen to the manifest inside my source code management inside GitLab, that will be reflected inside the Kubernetes cluster. To make things even easier to show, let me show you what do I mean really here, right? So I have 3 projects here, right? Just by the way, when just for your knowledge, what I mean by GitLab groups, subgroups, and projects, right? So I have under my CI/CD workshop subgroup, I have this project to created. It's a very simple project. This is for the agent that's deployed in AKS, right? So basically, this is the server side. Let me show you the client side. So if I just switch to my AKS cluster, and just let me get the pod from there. And okay, so this is the agent namespace, and you see here I have an agent deployed in my AKS cluster. And if I switch even to the EKS, I have another cluster completely. Now this one is sitting in AWS, and also if I do the same command, you see that I have an agent as well here. Once it loads, I have an agent also lives here, different than the first one, and same applies if I switch to the GKE. So the server side of this agent is just simply a project, and inside this project, this is the source code management of the server side of the project. And basically, what is doing is I'm saying, Mr. Agent, which is this one, okay, please can you give access, the CI access to these projects, and this is the project I will use for today's demo. And also in GitLab, you can do management for the Kubernetes cluster using a project template called GitLab cluster or GitLab cluster management. We'll not cover that, excuse me, today. And also, what I'm doing here is, Mr. Agent, also, if you please, in this project, actually, let me open the editor inside GitLab just to show you. So what I'm doing here is, Mr. Agent, as you are running, please, can you please keep an eye on this folder in my project, which is this folder here under the apps, under whatever, anything here, anything that changed here, please reflect it to my cluster, right? Now, if I go to the second project, this is the EKS cluster agent. And by the way, registering an agent is very, 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 very simple and straightforward thing. So basically in the GitLab, you can go into Terraform or into Kubernetes cluster, right? And once you have that folder structure in, excuse me, inside your GitLab project, all what you have to do is create this folder structure, which is .gitlab agents, and then whatever the agent name, and then the file is config.yaml. And then all that you have to do is come here and do Kubernetes clusters, and then you can connect to a cluster agent. And then all what you have to do is choose. In my case, I've already chosen my cluster. All what you have to do is choose this one and click register. And that's it. And then GitLab will prompt you with the command line that you can copy and run into your Kubernetes cluster to deploy the agent. And that's it. They are connected. As simple as that. So it's a very, very, very straightforward process. Once you have done that, then basically you have full control on the agent from your config.yaml. So just a quick recap here. What we're trying to do is, we agreed that I can have my runners, simple runners, live within the different Kubernetes cluster, and I can have them registered against groups and projects inside GitLab. But the most challenging or the most common scenario is when you want to deploy cloud native applications across even multiple Kubernetes clusters running across different cloud providers and different technologies, different Kubernetes, flavors from these different providers. And in my case here, I'm just showing AKS, EKS, and GKE. The recommended way, here it's your choice. Either you take it the traditional way, simply you write your own code, and then excuse me, and then it's up to you to run to manage the credentials, the connection credentials to your backend Kubernetes cluster, and then per runner can connect to these clusters. This is the traditional way, right? But when you have multiple vendors and multiple Kubernetes cluster, it becomes challenging, right? So what we can do is streamline that way. Simply, you can have projects in GitLab for your Kubernetes agents, basically, and then that will enable you to deploy a Kubernetes agent in each of these clusters. The value is, right? I'll show you. This is my software, my code here, a simple project, right? And all what I'm doing here in this project is I am doing in the variables. I'll just show you the environment variables. If I go under variables, I'll show you. I'll reveal the values so you see what I mean. What I'm doing is that I am telling my pipeline, if you are doing a DAST environment, which is DAST, it is the review environment. DAST stands for Dynamic Application Security Testing. If you are doing that, then this is the kube context you will use. Where did I get that kube context? It has been passed to me by the AKS cluster, right? From the Kubernetes deployed here. And then if I am doing a staging environment, which is in many cases, it is the case, I want a staging, or if you like to call it a pre-production, then this is the kube context I want to use. This is the base domain I want to use. And let me show you, this is the staging. And this is the kube context I want to use. And as you can see, I am using the EKS cluster kube context. Again, this kube context is coming from the Kubernetes cluster on the EKS cluster, which is this one, right? And in the third one, if I am doing the production environment, then please use for me, I just want to show you, which is this one. Then please use the ingress base domain for the GKE and use the, sorry, this one. And then use the GKE, the ingress domain for this is the AKS one, but then you should be using the production environment, the GKE for the production deployment, right? So this is what I mean by have different agents. Installing them is a very simple thing. It's just a simple project, and then you register that agent. And then all what you have to do is in the agent, you decide which projects or groups you want to pass the kube context for that agent, for that Kubernetes cluster to. And in my case, this is what I'm passing it to. The end result is if I come here and run my pipeline just to show you what I mean, is that run pipeline, right? And then let's run it on the master branch and show you what I mean. So the end result here is that this is the whole pipeline, and I'll show you in a second where these jobs came from, but this is the whole pipeline. This is the review environment, which will be used by the DAST. For those who don't know, DAST is the Dynamic Application Security Testing, and to run it, you need to have a running version of your application. Now, the good thing is if you are doing cloud native application against a Kubernetes cluster, GitLab will provide you with the job that's responsible to provision, to create a namespace and provision a sample of your code in that Kubernetes cluster, and then pass the resulted URL for that deployed application to the distributed application security, to the dynamic application security testing. This is the staging environment, as we agreed, it should be now deployed in EKS. So this one here, the review will be deployed in Azure on the AKS. This one will be deployed in the EKS environment, and then the production environment, I'm deploying it in the GKE. While this job is running, two things I want to highlight here, and I think we have like 6-7 minutes left. Two things I want to highlight here. You see this column here of like all the scanning jobs. These are the scanning capabilities provided by GitLab, which means I will be able to run them on basically on every commit. It's of course it's your choice when you want to run them, but the recommendation is on every change you are running, the corresponding security test should be included in your code. Second thing, in order to do all of this awesome end-to-end pipeline, right? You really don't need. Actually, you have two choices here. This is the pipeline file in GitLab. It's called .gitlab-ci, right? This is the content of the pipeline file I've written, right? You see all what I've typed? No, I haven't typed any single thing here, like zero, absolutely zero. Why? Simply because when you create this one, in order, we have been working with customers in the automation and CI/CD for a pretty long time. So what GitLab have done is we have put together and summarized together all the best practices for building a DevSecOps pipeline, and we provided that to our customers for free in what we call Auto DevOps. Right. So just to show you, so if I go into the web IDE here, while that pipeline is running, we'll come back to that one. Right, and this is my pipeline, and then you see here the choose template. This is what I'm referring to. This is like when you create a new pipeline, all what you have to do is just come here and choose Auto DevOps. Basically, it's the same job, right? It's the same file, right? So really, I didn't write any line of code. It is the same file. I just used that one. So what I have done is customizing the behavior of Auto DevOps, and I've done that through I'll leave this one, just by using or passing different environment variables, right, for the different environments I want to use. And in GitLab, I can set up, if I go to the variables, I can specify the same environment variable, the same name with different values, but for different environments. That's why I was able to say for cube context, Mr. or whatever you want to name it in your code, right? If you are running against a DAST, if you are doing the DAST review or the DAST, then this is the value. It's hidden. I'll just repeat it. This is the value you should be using. Why? If you for Mr. Cube context, if you are doing the staging environment, please use this value for the Cube context environment. And again, to recap, that value is coming from the Kubernetes agents, the GitLab agents for Kubernetes that I've described before. So if I go back now to our pipeline, and hopefully it has progressed from the build job. Yep, it has. So you will see that I have my scanning capabilities, the scanning have done, and now it is deploying for me an environment. So this environment, and you see here, you'll see this one, it switched to my AKS because I have asked it to use the AKS Kubernetes cluster, and this is what it will be using to create for me a Kubernetes a deployment for my application inside the AKS Kubernetes cluster. So it is installing it now. We'll keep it running, and let's just also you can monitor your environments just by going here and deployments. You see deployments and environments. Let me open this in a different tab. Okay, yep. It has deployed, and you see it has deployed under against. This is the URL for my deployed environment, and this is the AKS. And so you believe me. So if I switched here, sorry, oops. If I go switch to the AKS and kubectl get services, and you will see that the URL, this is the external IP address for that environment, and that's exactly the IP address I'm using here, the 96. So this is deployed in my EKS environment. And also, if I go here and go and do kubectl get pods, this one of the agent, and it is in my namespace. You see that this is the one, the pod 89 seconds before. This is the one that is deployed now in this environment. Now, as the pipeline continue running, and this is like what the environment I was referring to before, as the pipelines continue running, you will see that it provision for me in next one a staging environment, but this time it is running inside this one. Okay, it's now running the staging, the DAS job against that environment that was created before. And by the way, at any time I can go to the security tab and filter out for the security findings. So let's keep this one just running, and let me use the last 2 minutes here to quickly recap on what we described. This session, I tried to cover how to run across multiple cloud environments in multi-cloud environment. And as I said before, multi-cloud environment can be just different tenants. Each of them is running within their own cloud provider. That's perfect, awesome. We can do that because simply we can have runners deployed and runners are the execution engine, and they can be deployed across different cloud environments. The next thing we talked about is how can we run the same pipeline but across different cloud providers for different environments. This is the next level of complexity. Then the third thing is, what if you are doing what if you are doing cloud native applications deployment, right? And this is where most probably you will go for Kubernetes clusters. And then each cloud provider has its own flavor of the Kubernetes cluster. And this is where something like GitLab agents can be very, very handy in the picture, because simply I can have agents living within my Kubernetes cluster. That will save me the whole headache of managing and control and securing credentials and the connection and certificates to connect to the Kubernetes cluster. That's all offloaded from the project. All what I have to do is, these projects are responsible to manage the connection, the Kubernetes agent. These will control which projects can use that Kubernetes cluster simply by passing that cluster to them. And then in my project, all what I have to do is just use that kube context and just do the deployment. And this is what I was trying to show here in the demo. We saw how the review app was deployed in AKS. While now, if I click on the staging environment, you see that it is deployed in the EKS this time. So the URL is completely different now. It's deployed in EKS. And the other way to check that is just by going into deployments, environments, and you see that I have staging environment, and I can always run that environment from here. And you can control the stop and restart and redo the deployment. And by the way, yes, in GitLab, I can have an incremental rollout for my environments. Now, the very, very last thing before I conclude is, if I click onto the production environment here, that if I go in my pipeline, by the way, I'm intentionally made it as blocked, because many customers say, we don't want the pipeline to go directly to the production, so you can make this environment as a protected one, and then only assign some people to run the deployment here. So this is where I have the privilege, and then I can run the deployment. And then in our case, that deployment will go into the third cloud provider, which is Google. Basically, that concludes my session for today, and I hope it was useful and up to your expectations. I'm more than happy always to take questions if there are any questions in the chat.
Yeah, thank you, Summer, for your session. It was really interesting. And I would like to also invite you to ask some questions on Q&A chat. And in the meantime, I have some my questions prepared after your presentation.
Sure.
So first of all, maybe of course it was a demo. You can't share with us any production, let's say, environment production configuration. But what are, let's say, your experience, or maybe have you ever had the possibility to see how it works on the customer side, on the real system, real configuration? What are your pros, cons,
Yeah.
observations?
Absolutely, absolutely. I'll tell you from an actual experience I had with one of the big enterprise customers, even here in Australia. Their challenge was mainly that they couldn't run their automation pipeline within their AWS. They were using even one cloud provider, but within that AWS, they were forced because of their previous legacy automation tool. They were forced to run that automation tool in totally different environment.
Mm-hmm.
And then they had to go to the networking team and say, team, please, can you open the door for us in your network every time we need to do the deployment back and forth, back and forth? That was a huge challenge. So having GitLab deployed within their VPC, within their subnet, within their networking inside AWS per tenant, a huge relief for them. Because that means that simply I am running next to and I am the tenant. Think of it as an environment or an enterprise where you have literally tens of teams running, and they all need automation, right? So I am passing the control, Mr. Tenant, here is your automation engine running, or automation execution engine running in you. I am managing GitLab as a DevSecOps platform, but the runners are your responsibility now to provision and manage. So, yep.
Okay, great for that.
Thank you.
Very interesting. Okay, I can see. Check the chat again, but I can see an additional question. So thank you, Summer, for your time, for your presentation, which was really interesting and inspiring.
Sure.
I would like to also invite you and all of us invite to the closing keynote within 3 minutes. I hope it's on the first track. So yeah, I would like to invite you to be there also.
Sure.
And thank you again for your presentation, for your time, and for your
Absolutely, my pleasure. Thank you for inviting me. Thank you very much.
Thank you. Have a nice day. Bye.